Hello and welcome back to Data Science Brain. Today we are diving into the iris flower classification project, one of the most famous projects for beginners in data science. We will go through each step of the project, explain the code and understand the broader context. By the end of this video, you will be able to put one of the most famous beginner-friendly data science projects in your portfolio. Before we begin, make sure to hit that subscribe button and the notification bell so you won't miss any of our exciting data science tutorials. Also, hit the like button and share this video with your friends. Alright, let's get started. So, iris flower classification is a classic problem in the field of machine learning and pattern recognition. It involves the categorization of iris flower into different species based on their morphological features. The dataset commonly used for this classification task is the iris dataset. The iris dataset consists of measurements of 4 features of the iris flower: sepal length, the length of the iris flower's sepals, sepal width, petal length, and petal width. The goal is to classify iris flowers into 3 species: Setosa, versicolor, and virginica. Each instance in the dataset represents a specific iris flower, and the species of each flower is known. The task is to build a machine learning model that can learn from these features and accurately predict the species of iris flower when given new measurements. So let's begin by importing the necessary libraries. First, we will be importing the pandas library, which will be using for data analysis and also to read the data. It's an essential data manipulation analysis tool in Python, and we are assigning the alias PD to it, so that we'll be using PD to call the pandas functions. Now, if you don't have any of these packages installed, all you need to do is exclamation mark pip install and the library name. Now this will install the necessary package and click run. Okay, so this is all you need to do to install. Now I have already done this, so I am not going to do it again. So first we will import pandas and then import matplotlib library. We have finished importing all the libraries. I have fast forwarded. So matplotlib here will be used for plotting some of the exploratory data analysis, and Seaborn is also used for one of the plots that we'll be plotting. So also we'll be using scikit-learn library, sklearn. It is written as sklearn, and it's one of the functions in it, train test split, to test our dataset into training and testing datasets. And also we'll be using the k nearest neighbors classification algorithm. We can import that from sklearn as well, and we'll be using that classifier for our classification of the flowers. And also we will be importing other functions like classification report and accuracy score to check the accuracy of our model. Now let us import the dataset. So first let us store the URL of our dataset into a variable. Wait a minute. This is the URL of the dataset. We can I will be providing this URL in the bio, in the description. And let us define some column names. So these names will be used when this specifies the column names for dataset which will be applied during the data loading process. So I will show you what I am meaning. What I mean by that. Sepal length. So first feature will be sepal length. The next feature will be sepal width. We have already discussed in the video. The next feature will be petal length, and after that it will be petal width. That's the last feature. Then we will be having the class of the flower. So that's the last column name. So this link will be getting the dataset in the form of CSV file, and in that all 4 features, and at the end the last column will be class. So we are giving it column name so that these column names will be assigned to all 4 all 5 columns. The first 4 columns will be features and the last column will be the class to which we need to classify the flowers. So now let us load the dataset using pandas. So let's write iris data to pd.read csv. So this is the function that is used to read the CSV data that is coming from the URL. So we'll pass in the URL from which we need to collect data, and then we will pass in the names of the columns stored in the variable column names. So pd.read CSV is the function that we are using to read any CSV files. So in place of URL, we can actually provide the path to the dataset if it is stored locally. So since we are getting the data from this URL, we are passing in that URL instead of the path. Now let us run that code. We'll be collecting the data. Now after the data is collected, let us see how the data looks like. We can use the we can pass in 5 here. So if we check the type of the data, then we can see that the iris dataset is of type. So one more thing, if we are we have already stored the iris dataset inside the variable iris data. So once we have entered iris, then this, if we press tab here, the Jupyter Notebook will suggest the variable name, so it will be easier for coding. So when we check the type of the dataset, we can see that it's a data frame. So it's a pandas data frame. So in dot head is a function in pandas that is used to display the first 5, or maybe we can mention the number of rows that we need to see here. We mentioned 10 there. It will show the first 10 rows inside that data frame. So it's a pandas data frame. The type of the data is pandas data frame. So we can see that the sepal length, so it has 4 columns as we have mentioned here. We have passed in the column name, so it has divided the data into 5 columns. First 4 columns are the features: sepal length, sepal width, petal length, and petal width. The last column is the class which we need to classify this flowers into. So this won't be showing all of it. Maybe let's see the first 50. So we have 150 data, I think. So each of these are divided into different one of the flowers. So we can see that starting from 95, I think, or maybe, so it's I think how many are there? Let's check in a total number of. Okay, there are 150 rows. So that means 150 divided by 3. It will be 50 of iris setosa, and it will be 50 of versicolor and 50 of virginica, I believe. If we print 60 here, we might be able to see. So this 49. Okay, 50 of iris setosa and 50 of iris versicolor and 50 of iris virginica. So that's the number of flowers in there. So let's go back and put 5 here. So we can see that the sepal length, sepal width, petal length, and petal width of iris setosa is given us like this. So these features are used to classify this flower into. So each row represents a flower, a unique flower, and this sepal length, sepal width, petal length, and petal width, shows us that it is this particular flower. So these are the features of that particular flower. We can see some other flowers for differentiating this. So we can use the ilog function of the pandas data frame to view the data starting from 50. So okay, we made some mistake. Okay, ilog should be like this. Yeah, so we can see data set starting from 50. Okay, we need it till only the 100. So yeah, so now we can see the features of versicolor. We can see that the length, sepal length is slightly higher. Sepal width is also slightly higher, I believe. So that's the features of iris versicolor. So now let's see. Okay, let us use another function, describe, and let us this function will describe different features like mean, standard deviation, the minimum value, the 25th percentile, 50th percentile, 75th percentile, and the maximum value of the dataset. This is also one of the most useful tools for data analysis. Now, in this particular project, I don't think this is much useful to us, but we can say that in the minimum, the mean width, sepal length, and also petal width, we can see that. But other than that, this is not of much usefulness in a classification project, in iris data classification project. So let's move on to the next data analysis that we can possibly do here. So what we can do is we can actually do a plot, sns.pair plot, and pass in the data, and you can pass in a hue. So the hue will be hue equal to class. So what this means is that the colors will be based on the different classes. So there are 3 classes, so there will be 3 colors in which this pair plot will be shown. Utility.show. Utility.show function is used to show the chart. This will create the chart and this will show the chart. So let us see the chart. Okay, where is that? Okay, yeah, you can see it here. I will make it smaller so that you can see. I will make it larger so that you can see. Okay, I hope it is visible to you. So from this pair plot, we can see that. We can see that there are 3 classes here: iris setosa, iris versicolor in orange, iris setosa in blue, iris virginica in green. You can clearly see that in every plot, iris setosa is completely differentiable from iris versicolor and virginica. The blue dots are clearly separated in all of the features, like in sepal length versus sepal length, sepal width, petal width, petal length. In all features, iris setosa is really different from iris versicolor and virginica. So the classification for this flower will be really easy. And also we can see that there are considerable difference between iris versicolor and virginica, because the orange dots and the green dots are they are not completely together. Yes, for the sepal width, I think sepal width and sepal length comparison, it is pretty close together, but other than that, it is pretty differentiable in itself. And also we can see that iris setosa has the highest sepal length and petal length as well. So that is one of the data analysis that we can do from that. And we can also see that iris versicolor and virginica has similar petal width and petal length. So yeah, you can do several data analysis like that from this by using this pair plot. So from this we understood that there is considerable difference between these 3 flowers, and there are some features that actually differentiate it much better than other features. Like for example, the petal length differentiates all 3 of them quite well. So yeah, so that's what we understood from this pair plot. Now we will do the classification. Now we will split the data into training and test set by using scikit-learn library. I will zoom in so that you can see it much better. We have already imported the library. So we use X to represent the class to which we need to classify it to. Basically, okay, one more thing I need to mention is that these 4 features are known as the independent features, independent variables, and the class to which we need to classify this into is known as dependent variable, because this class is dependent on these features, isn't it? So these are independent features, independent variables, and this is the dependent variable. So this variable is dependent on the values of these 4 features. So we use X to represent the independent features. So iris dot so let us store all the independent features into the variable X. One way we can do that is by dropping the last column, isn't it, from axis 1. So we are dropping the last column from, last data set of data from axis 1. Axis 1 here mentioned means that we are dropping it from the columns. So we are dropping class from columns, and just need to see that. We can see that now X contains only the features. Similarly, we can store. In Python we use small letter y to represent the dependent variable. We can store the class dependent variable to y. You can see it. You can see that the dependent variable, our class names are stored in y. Now we will use one of the most famous libraries, the k-nearest libraries. Nearest neighbor classifier to classify, create a classification model. Okay. I've imported it as nearest neighbor classification. Okay, and we will pass in this one of the important hyperparameters. How many neighbors we need? So the number of neighbors, n neighbors means the number of neighbors. I think we have made a spelling mistake here. So in the KNN algorithm, the term neighbors refers to data points in the training set that are closer to the data point under consideration. So the distance between data point is typically calculated using metrics such as Euclidean distance between the data sets. And n neighbors, the hyperparameter that we have passed in here as 3. It's a hyperparameter that we set before training the KNN model. It defines the number of neighbors to consider when making the prediction. So a smaller n neighbors value makes the model more sensitive to local patterns in the data, but might be sensitive to noise. A larger n neighbors value makes the model more robust to noise, but might over smooth the decision boundaries. So how to choose one? So when predicting the class of a new data point, the KNN algorithm looks at the classes of its n neighbors. Like we have passed in 3 here. So it will look at the 3 nearest neighbors and see which class it belongs to. The algorithm then assigns the class that occurs most frequently in these 3 neighbors to the new data point. So the choice of 3 neighbors is somewhat empirical and often based on the experimentation. So it's a balance between considering enough neighbors to capture the local structure of the data and not choosing too many, which could lead to oversmoothing. So in practice, the optimal n neighbors value can vary based on the characteristics of the dataset. So since we have here 3 classes, I have chosen here 3, but this is done based on some research. You can learn more about that if you want. So yeah, that's about the n neighbors. Now since we have chosen this, let us fit this model. nn.fit. Let us fit this k-nearest neighbors classifier. Fit our data to it. So this will train our k-nearest neighbor model using the dataset that we have created here. Okay, I think we forgot to create the dataset. We have forgot to create the dataset. Actually, split the dataset into training and testing set. So first, before training the model, we need to split the dataset into training and test set. So one set of data, the training data will be used to train the model, and the test data will be used to test the model. So we need to split it for both the dependent and independent variables, dependent and independent features. So this is how we do it. We will be using one of the functions that we have imported earlier, the train test split function. We use that and we will pass the data that we have created here. We have separated it as independent and dependent variable before, and we will pass in some of the parameters like test size. is equal to 0.3. Let's explain what these parameters mean. Random state equal to 42. So what this 0.3 means is that it will reserve 30% of the data for testing. So 30% of the data will be passed on to X test and Y test, and 70% will be reserved for training. It will be passed on to X train and Y train variables. And the reason why I have put random state equal to 42 is because when I am splitting this data, okay, I think we have made a mistake. X is not defined. Okay, we made a mistake by putting it small letters. Let's run again. So by putting random state equal to 42, whatever this data is split into, whoever is watching this video, they will also get the same data same split in data. So random state equal to a number, whichever number I am giving here, if you are giving the same number here, then this data set that is stored into these variables will be same for both of us. That is the reason for using a random state equal to 42. So if I am going to put here 41 and you will be putting there 42, we will be getting a different data set that is stored into these four variables. But if you are putting 42 and I am also using 42 number as a random state, we will both be getting the same data set that is split into these four variables. That's the reason for using random state there. Now let us fit this data. So we use the fit function from KNN library to fit this KNN neighbor library to fit our training X train and Y train, our training dataset that we have split here by using scikit-learn library, scikit-learn function train test split, and we have fit our training and training data to it to the classifier. Now after we have fit it, now we will check the accuracy of our model. We will evaluate our model. So we use our test dataset for that. We use the test dataset to check the accuracy of our, to evaluate our model. We'll pass in our X test, the futures, and see what all classes it has classified it into. So it will predict. And now we will compare. The predicted values to the actual values. The actual values is stored inside the Y test variable. So we will compare both. Let's see. Discord. We pass in the actual values stored in Y test and the predicted values stored in Y pred. Let us see the accuracy of our model. We can see that it has occurred an accuracy of 1.0, which is the highest accuracy, which means that we successfully classified our test data with the accuracy of 100% accuracy. So it means that the values of Y test, values inside Y test is same as values that our model has predicted. That means that for all the features inside X test, it has classified successfully with 100% accuracy. So the values of Y test is same as the values of Y pred. The predicted values are same as the actual values. Now we will also see another model evaluation. We'll get a classification report of these both. Also another useful tool to evaluate your model's performance. So we can see that the precision recall and F1 score and also support of our model. So we can see that the precision recall and F1 score both are giving back values as 1 because it has given us 100%. It has successfully classified our test dataset using 100% accuracy. That's the reason why we can see precision recall and F1 score as 111. Now, if you don't know what precision recall and F1 score are, I will explain. So precision is the ratio between correctly predicted positive observations to the total predicted positive observations. So what this means is that the total to the total predicted positives. So what it means is that it is is a ratio of true positive to true positives plus false positive. So in the context of our values, for each class iris setosa, iris versicolor, and iris virginica, the precision is 1 because it indicates that all predicted positive instances for each classes were correct. Now what it means is that we have got all true positives and we have no false positives. So the value of false positive here is 0. That's why the numerator and denominator will become equal. That's why we have got a value of 1 for precision. Similarly for recall, recall is the ratio of correctly predicted positive observations to the total actual positives. So correctly predicted to positive to total actual positives. So actual positives can be given as true positives plus false negative. So if we have classified something as false negative, but it was actually positive, that plus the true positive that we have correctly predicted. So that will give the sum of that will give us the number of actual positives. So recall is the ratio between true positives that we have predicted correctly to the actual number of positive values in the dataset. So this will also give us a value of 1 because since we don't have any false negatives, we haven't falsely classified anything as negatives. So the numerator and denominator will be equal and the value of recall will be 1. Now F1 score is the harmonic mean of both these values, precision and recall. It provides a balance between precision and recall. And the equation is as seen in the screen. It is 2 times precision and recall divided by precision plus recall. Now F1 score will also return 1 because the value of precision and recall are 1. So it will be 2 into 1 into 1 divided by 2 divided by 1 plus 1, 2. So it will be 2 by 2 and the value returned will be 1. So that's about precision and recall. So now that we have successfully created our k-nearest neighbor classifier model using the dataset, and we have got an accuracy score of 1. We can see the accuracy score here. It is 1. It's 100% accurate. So let us try to make a prediction on a new dataset, new data that the model hasn't seen. Let us pick one from the test dataset itself. Let us print the X test. Let's take a look at this and let us see which dataset this will be. Which class the model will classify this into. Or maybe we can actually select one of the datasets that we actually know the class. Let's say, okay, so for this we know that this is a Iris setosa class flower. Let us see the model can predict this correctly. Now this is a really bad example of how to test your model. Don't do this because this will definitely classify it correctly, but it's showing you an example. The model has already seen this data, so it will definitely classify this correctly. This is not a good example of how to test your model. Just for an example purpose, I am showing this. After that we will actually test it on a completely new data. Sepal, and hope I have spelled it correctly. Maybe 5.1. Let us store this somewhere so I can see it better. Length 5.1. Sepal width. We are creating a data frame here. So this is called a data frame. It's a pandas data frame, like a dictionary in Python. We're creating a data frame with all the future name, and we are passing in these values. That we can pass this to our model that we have created to test and see if our model actually correctly predicts it. We already know this class to be Iris setosa. We can see if it is correct in real time. We have created the make sure it's correct. We created the sample data, and let us create a prediction. KNN is our model name, KNN. Predict is the function that we use to predict the class on our new data that we have created here. So let us print the predicted class. One of the funny things that you will see here, I will print this prediction. So you can see that it's an array, and as the first value, it has printed as iris setosa. Print first value inside it. So it has classified this as an iris. It's a setosa flower. So we already know that it is a setosa flower because we have picked it from here. It is a setosa flower, and it has successfully classified it correctly. Now let us give it a totally different, totally new value and see how it classifies this. Let's say this is 5.7, length is 4.5, length is that, and now let us see what class it will give. Okay, it is still classified as iris setosa. So let us use different values. Let's see. Oh, okay. This is always predicting it as iris setosa. Maybe it is correct. Let's try one more time to see if it gives us a separate different value. Okay, it has given us iris virginica. Okay, so let us check our dataset. What is the name of our dataset actually? Iris data.head. Okay, let us see if the value of Virginica was actually starting from 100, right? So let us see. Yeah, we can see that the petal width of iris virginica is higher. So that's why we have given 2.9 here. So it is similar to the values that we can see here. And also the sepal length is also close to 6 and 6 plus. And also sepal width is also on the high side. So that's the reason why it has given us, it has correctly predicted it as iris virginica. We can ensure, we are sure that this classification model that we have built using the k nearest neighbor classifier, using the test and training dataset, is successful in predicting any new data that is given to it. So let's see what we have done in this project. So we have learned how to import all the necessary libraries, pandas, matplotlib, numpy. We haven't used numpy, seaborn, and scikit-learn. And we have seen how to get the dataset from the URL by using the read CSV function from pandas. And we have seen also how to view the first 5 data of the dataset by using the head function. We can also pass in different values here to see the number of that many number of rows. We have also seen a describe function to view some of the statistics of our dataset, like mean, standard deviation, and different quartiles. And also we have done a mini data analysis, like exploratory data analysis, by using the pair plot from seaborn library. And also we have seen how to create test and how to separate the features from the classes, from the class, and the dependent variable from the independent variable. Also we have seen how to split the dataset into training and test set. And also we have seen how to use the k nearest neighbor classifier function to fit our dataset for making a k nearest neighbor classifier model. I created the model, and we have done a test using our test dataset, and we have received an accuracy of 1. It's 100% accurate model, and we have learned what precision recall and F1 score are. If you need any explanation on precision recall and F1 score, I have just simply explained it, and there might be some doubts. If you need an explanation, you can put it in the comments. I will do that video. And we have seen that, we have also tested our model on a new dataset that we have created. It is successfully classified, and we have checked it by actually viewing the dataset. We can see that it could be correct, because we can see the sepal length and also the petal width are similar to what we have given it, and it has correctly classified it as iris virginica. So that's all about this video. I hope you have enjoyed it. If you found it useful, kindly like the video, subscribe to our YouTube channel, and share this video with your friends. I'm hoping to do much more projects in the future. You can comment it down, the projects that you want me to do. I'll try to do it at my best. So I'll see you in the next video. Till then, happy coding.